This is the final topic we'll cover in trig and Pythag, and it's called directions and bearings. So what we'll look at first of all is these things called true bearings, and a true bearing to a point is the angle measured in degrees in a clockwise direction from a north line. And when we give true bearings, what we do is we use 3 digits to describe that true bearing. So we always take it from facing north. Okay, so this is the compass with our 4 cardinal points: north, east, south, and west. Never eat soggy Weet-Bix. And what we do is we imagine using this compass, if I was standing here, if I was facing in this direction here, I'd be facing north. This could also be described as a turn of 0 degrees or a full turn of 360, but I'll explain that in a sec. Right, if I turn 90 degrees clockwise, what I do is I end up facing east. And if I turn another 90 degrees clockwise, I end up facing south. So to turn to south would be 180 degrees. I can turn another 90 degrees, and that will have me facing west, 270 degrees. And finally, if I do this last turn here of another 90, what I do is I end up doing a full 360 facing north again. So they're our true bearings there. So we can say that north is 0 or 360, east is 90 degrees or a true bearing of 090, south 180, and west 270. All right. So it says here, state the true bearing of the point P in each of the following diagrams. So imagine we're starting here at the, let's call this the origin, and we're going out to point P. What true bearing do I need to follow? So we can see here that from north, the angle opened up is 48 degrees. So our true bearing is 048 degrees. Okay, so remember, it's given as 3 digits. Okay, this one here, I imagine myself facing north, and what I want to do is get to point P. So that requires me to do a 90 degree turn, plus another 90 degree turn, plus a 60 degree turn. So this would be 90 plus 90 plus 60. So that's 180 plus 60 is 240 degrees. And you'll see sometimes they put the letter T there to indicate that that's a true bearing. Okay, this one here is going to involve us going 90 degrees here, plus whatever this amount is here to get to point P. Now, I know that it's a full 90 degree turn to get from east to south. So if I remove this 40 here, that means that this distance must be 50. So this one's going to be 90 plus 50, which is 140 degrees true. Right, this final one here is going to involve me facing north and going 90, 180, 270 plus 20. So that's 270 plus 20, 290 degrees true. Alrighty, let's try an application of that. So a bushwalker walks 5 kilometers on a true bearing of 150 degrees from point A to point B. How far east is point B from point A? Well, the truth is I don't know. Until I draw a diagram, I really can't see this. So the way to do these ones here is to put together a compass, labeling north, east, south, and west. Now, a bushwalker walks 5 kilometers on a true bearing of 150 degrees. So this would be 90, and how far more would we turn to go on a true bearing of 150? That would be another 60 degrees. So I'm just roughly guessing 60 degrees. What I'm going to do is extend a line out there. So I'm going to label that 60. Okay, this line here is or represents the walk, which is 5 kilometers long. Now, what do I want to do? I want to work out how far east. So what we do, this is point A here, and we end up at point B. I want to work out how far east this point is from point A. So what that is, that will represent this distance here. Okay, this is actually what I'm after, because this is how far east point B is from point A is. That's the easterly distance. And so we can complete the diagram by drawing a line from here to here. That was meant to be a straight line. From there to there. And you can see also what's happened is that I've drawn a right angle triangle. So what do I know about this right angle triangle? I know that this degree measurement here has to be 30. If that's 60, that's 5 kilometers, and we're after this. So let's just quickly redraw that. Right angle triangle, 5 km. This is the unknown, we'll call that x, and this is 30. So you can see here that what I've got is the opposite and the hypotenuse. So x is going to be given by the sine of 30 degrees equals x, which is the opposite, on hypotenuse, which is 5. X is equal to 5 times the sine of 30. Now I know that the sine of 30 is a half, but you should do this on the calculator. So I'll just show you. So we've got sine of 30, which is a half, and we're timesing that by 5. So 5 lots of a half is 5 on 2, or 2.5. So we'll go, let's write that as a decimal, 2.5. And let's have a look. The unit is kilometers, so it's 2.5 kilometers. So how far east is point B from point A? That's this distance here. That's 2.5k. So you can see the important part with answering this question here is to draw the triangle, draw the diagram here, and yank the triangle out. That is just a standard right angle triangles, one side unknown problem. All right, the last one is a bit more advanced. Okay, and it says here, state the true bearing to return to the origin from point P in the following diagrams. So this is the same first question as this one is here, but instead of actually stating the true bearing from here, the origin to point P, what we want to do is imagine that we're at point P and we wanted to get back to the origin. So what bearing would I follow? So again, I think the simple way of doing these is to imagine a compass here, north, east, south, west. So if I'm point P, I need to turn 90, 180, and whatever this measurement is here. All right, now how are we going to get that measurement? So the way we're going to do it is to note something here, that there's this rule that says if this is 48 degrees, this also will be 48 degrees. Now, how do I know, or why is that the case? Let's just quickly draw the right angle triangle. All right, so what I know is if this is 48, this one here must be 42. All right, and if this is 90, what we've got is 90 and 42. Where's my mouse? 90 and 42, so I'm going to stick them together, and the answer is 132. So this angle and this angle here is 132. So whatever's left over from 180 must be what this angle here is. Okay, so I'm going to do, on my calc, I'm going to do 180, take away 132, and surprise, surprise, I get 48. So that's how that rule works. That angle there is the same as that angle there, so that's going to be 48. So to answer this question, I need to turn 90 plus another 90 plus this 48 here, and then I'll be facing in the right direction to set off back to the origin. So 48 equals, what's that? 180 plus 48 is 228 degrees true. All right, same deal with this one here. We're at point P and we want to get back to the origin. So again, what I do is I imagine kind of like a north, east, south, west, a compass there. All right, so I'm facing north and I need to turn this distance here, and then I'll be facing in the right direction to return to the origin. So what's this one here? Well, it's the same idea as last time. If I know that this is 60, I know that this has to be 60 as well. So it's going to be 0, 60 degrees, true. All right, so that's example 3. That's a bit more advanced there. Okay, so these are the questions. And for advanced, try question 3, but do the technique that we've just done there. Instead of doing it from origin to A, do it from A to origin. Good luck.